Hi, in this video we'll do a general overview of the Charli3 Oracle Substrate Partner Chain. For this demo, we will explain briefly how the partner chain is created and how the block producing committee is registered. Then we'll showcase the partner chain in action, going from the publication on the partner chain network of the data feed to the results of the reward distribution algorithm. This Oracle partner chain was built using IOG's partner chain node as a base. We studied the node and the functionalities it provides before integrating the Oracle functionality that we had developed previously. For testing purposes, at first we used a local testnet that is also provided with IOG's partner chain node, but the final goal here was to have a partner chain connected with SPOs live on Cardano. So we had to deploy 3 SPOs of our own on the preview testnet. In this video, we will show you 3 Oracle partner chain nodes connected with the SPOs. The creation of the partner chain and the registration of SPOs as block producers are utilities that come with IOG's partner chain node, and it was slightly modified for this use case. So we will briefly explain how these processes go before moving on to our live example. Before beginning the chain building or registration process, there are a few things that have to be set up. First and foremost, we need to have the Oracle partner chain node executable, which can be obtained by running cargo build on the root of the Oracle partner chain repository. This will build the node executable and the artifacts needed to complete the chain building and registration. We also need to have instances of Cardano connected with Ogmios, Kupo, and DBSync. Thorough instructions on how this can be set up can be found in the repository. Every SPO has to execute the generate keys command before the chain builder, as they need to provide the Aura key and a Cardano address that they own to the chain builder. The chain builder has to collect everyone's keys and generate their own, then configure some initial details to build the chain specification that has to be distributed to the nodes. Once it's finished, we have to set up the D parameter, which is a configuration pair that determines the number of permissioned candidate seats and registered candidate seats. An important thing to note about this step is that this configuration takes 2 Cardano epochs to be available, so the next step is to wait. On the preview network, this can take between 1 and 2 days. After 2 days, we can finally start the chain. Once the chain builder has initiated the chain, SPOs can register themselves as block producers. First, make sure that the chain builder is running the initial node. At this point, the SPOs have received the chain spec file directly from the chain builder as well. Then the SPO can begin the registration, which is divided into 3 steps. This is because the registration requires the signature of the SPO, which is extremely sensitive information, and the division allows the SPO to sign it in an offline machine. The CLI gives a detailed description for each registration step. Registration is effective after 1 to 2 Cardano epochs. After that, the partner chain node is registered on the partner chain, and it is a selection option for the consensus committee. There are various steps in between the chain building and registration that take a lot of time to become visible. That's why we aren't showing them in real time and have decided to just skip to the actual execution of the substrate chain, since we already have our nodes registered. So now we will finally look at the partner chain in action. For this, I'm using a virtual machine where I'm going to initialize 3 nodes. Each one is linked to an SPO and is already registered as a block producer. It takes some time for the nodes to initialize and sync. After a while, we'll be able to see that they started producing blocks. It is also worth mentioning that for this example, the blocks have a duration of 5 minutes, which allows us to run them for a long time without saturating the free tires of the APIs that we use to fetch the prices. But this duration is configurable and can be much shorter. For now, we can use the Explorer to visualize some information. For example, we can query the storage for the aggregated data feed. This is done in the same way that we showed in the previous video. And for example, in this case, the aggregated feed is 737. We can also view the status event and see that the 3 nodes participated and the 3 nodes provided a good price. And here we can see the new field about the reward distribution. This is the addresses of each of the nodes, since every node participated and every node provided a good value. But aside from this, another thing that we thought would be interesting to show you is the way to make queries without using the Explorer, since this isn't like the most efficient way to make queries to the event or the storage. So we made a few example queries using a Python library called Substrate Interface, and I'm first going to show you how they work. For example, here I'm going to query the aggregation status. This query can take a bit, but we can see here the same list of information that we saw in the Explorer, but of course in this way we can access it in a more usable way for a program or whatever. Another interesting query would be to the storage. For example, in this case I'm querying some fields of the configuration of the Oracle. And here we can see the information that is set up in the configuration. The code is very simple. It uses Python and it is quite straightforward to navigate. For example, the status event has many attributes and it is quite easy to look for each one. It is simple to initialize, since we just initialize using the RPC port of the node, and here we sign for the node extension that allows us to use this filter events method. Thank you for watching.